So what's the one thing that protects an astronaut from the absolute fury of re-entering the Earth's atmosphere? Well, believe it or not, the answer is hiding in your coffee mug. Today, we're diving into the frankly incredible world of ceramics.
Okay, think about this for a second. A simple coffee mug, an ancient terracotta warrior, and a high-tech reusable spacecraft. I mean, they seem worlds apart, don't they? But they are all connected by one single, remarkable material. It's a material that literally links our kitchens to the cosmos. Stick around and you'll see exactly how.
So to really get how this material made it all the way to the stars, we have to start somewhere a lot more familiar. Yeah, we're starting in the kitchen. Let's uncover the hidden science that's sitting right there in your cabinets. All right, let's play a quick game. Picture this: a mug, a plate, a bowl, and let's say a paper bag. Three of these things share a fundamental secret, a core material property. One of them is the odd one out. Any guesses?
Yep, if you guessed the bag, you nailed it. Your mug, your plate, your bowl, they're all classic examples of ceramics. And this proves a really crucial point. This quote-unquote advanced material we're going to talk about is something you probably use every single day.
So, what even is a ceramic? Well, at its heart, the process is surprisingly simple. You start with something soft and shapeable, like clay. You form it into what you want, and then you stick it in a super hot oven called a kiln. This intense heat doesn't just dry it out. It triggers a deep chemical transformation, creating a brand new material, one that's hard and unbelievably durable.
And get this is not a new technology, not even close. We've been mastering this for thousands and thousands of years. The earliest ceramic we've ever found, a tiny little statuette, dates all the way back to 28,000 BC. That is an absolutely incredible legacy for a material that is still shaping our future. So how exactly does that transformation happen? Well, welcome to the trial by fire. This is where soft, humble clay gets turned into a legit super material.
The real secret here is extreme heat. A kiln is not your kitchen oven. We're talking temperatures that can soar over 1,300 degrees Celsius. That kind of intense energy doesn't just bake the clay. It totally rewrites its chemical structure, and it does it permanently.
The whole process really happens in three main stages. First up is evaporation. All the water inside the clay gets superheated and escapes as steam. Then comes the real alchemy. The heat sets off these irreversible chemical reactions, creating totally new compounds. And finally, as it cools down, some of the elements that melted actually fuse together, locking all the atoms into a new, incredibly strong and rigid structure.
This whole trial by fire gives the final products some amazing abilities. Honestly, you could call them superpowers. So let's take a look at the unique properties that make ceramics so ridiculously useful.
You know, what's fascinating is that these properties are this weird mix of amazing strengths and interesting trade-offs. For instance, they're incredibly hard, that's why your fork doesn't leave a scratch on your dinner plate, and of course they're famously resistant to heat. They're also immensely strong when you squeeze them, but, and here's the catch, they can be brittle. And for all that toughness, they're surprisingly lightweight, a property that becomes super important later in our story.
Let's just dig into that whole strength versus brittleness thing, because it's really cool. A ceramic brick is unbelievably strong under compression. That's why you can stack thousands of them to build a house, and it won't get crushed by its own weight. But take just one of those bricks and drop it, well, it's brittle. It's probably going to shatter on impact. See? Two very different kinds of strength in the exact same material.
Okay, so with all these unique abilities, where else do we use them? This brings us to the unseen world of ceramics. All the applications hiding in plain sight, way beyond our kitchen cabinets.
Just think about how these properties get put to work. We use that hardness and compressive strength for structural things, like bricks. For toilets and sinks, we need clay to be malleable so we can shape it. Plus, we add a glaze to make it non-porous and hygienic. And, here's a good one, inside your car's exhaust, there's a ceramic honeycomb that can withstand insane temperatures, and it provides a lightweight structure for the catalytic converter.
And now, we get to take the leap from the everyday to the truly extraordinary. It's time to see just how far we have pushed this ancient material. Yep, all the way from pottery to planets.
All right, think for a minute about a ceramic oven dish. What makes it good at its job? Well, it can handle really high temperatures without breaking or warping, right? It holds on to heat. Okay, just hold that thought.
Because those exact same properties are why specially engineered ceramics are used to coat the turbine blades inside a jet engine. They act as a thermal blanket, basically.
protecting the metal blades from overheating as they spin thousands of times a minute. It's the same principle, just taken to a mind-blowing extreme. But it doesn't even stop there. The ultimate trial by fire for any material known to man has got to be re-entering Earth's atmosphere. And the material that we choose to protect our spacecraft and the astronauts inside, you guessed it, ceramics.
So why on earth are ceramics the perfect material for this seemingly impossible job? Well, it really comes down to three critical superpowers. They have extreme heat resistance, so they can actually survive re-entry. They are also terrible at conducting heat, which is a good thing. It means the fire on the outside never reaches the inside. And finally, their low density helps keep the spacecraft light enough to actually fly.
And that's it. That's the incredible journey of this material. You can draw a straight line from the very first person who figured out how to fire a clay pot thousands of years ago to the engineers who designed a thermal shield for a space shuttle.
It really makes you wonder, doesn't it? From medicine to computing to creating new energy sources, what future challenges will this ancient material, born from nothing more than earth and fire, help us solve next?